Now we're going to be talking about the horizontal circular motion and force vector diagrams. So if a bob is connected to a thread and moved in a horizontal circular path, draw the forces acting on the bob. So we're going to be having our tension force, and we're going to have the weight force. Using a vector triangle, explain why the bob moves in a circular path. So we're going to have the bob here, we're going to have the tension, we're going to have the weight. Okay, now we can write that the resultant force, let me just write this down first, resultant force of tension and weight acts towards the center of the circle. Okay, number one. And this force, this centripetal force, is perpendicular to the motion, or specifically the velocity of the bob. So I hope these 2 points are clear in understanding. I'm going to explain a bit more with the vector diagram. Okay, so we're going to pull back our tension force so that we have everything in the correct orientation. So we have the tension force here, and we've got the weight force. It's going to be like this. So we start from here, we go here, and we reach here. So start from here, the resultant force will be in this direction, which is towards the center of the circle. Now, I also want us to see this example where we have a circle which is kind of not vertical and it's not also horizontal. It's kind of an inclined circle at an angle. So we're kind of going to be looking at this. So we've got the metal sphere here, and it's got 2 forces. It's got this tension force from the chain here, and we've got the weight here. So weight, and we've got that tension force right there. So let's find out the resultant force. So I'm going to pull this back. This is going to be the resultant force. It's going to be the tension. We start from here, we go to here. Alright, so that's going to be the resultant force. And that's actually the centripetal force. So I'm going to draw the object again as a dot. And now I'm just going to show you the resultant force. So it's going to be, I'm just going to take it. So let's take it like this. Copy it. Let's paste it over here. Paste it, and let's put it on the object. So this is going to be the circular path the object will be moving in. This is going to be the centripetal force, and this is actually the resultant force of your tension and of your weight. We start from here, we go here, kind of like that. We can see this in the actual diagram as well. We've got the tension, we've got the weight. I'm going to pull back my tension force. This is going to be the direction of my resultant force. So I'm going to erase this, and then I'm going to take my resultant force and put it right over here. So it's going to be my resultant force, and my object will therefore be moving in kind of this circle, where this is going to be the centripetal force. So your answer is going to be that, I'm not going to write it down, it's the same thing what I wrote before. The resultant force of the tension and the weight is going to be the centripetal force. The centripetal force is perpendicular to the motion of the metal sphere. Okay, so this is basically going to be your answer. Try this example as well, a bit more simple. So we've got the aeroplane, we've got the lift force, and we've got the weight. I'm going to pull up the weight force, and this is going to be my direction of my centripetal force. We start from here, we reach here. We can do the same thing here as well. We've got the weight force, and we've got the tension force. So pull the weight back up. This is going to be your direction of your centripetal force. We start from here, we go down, we reach here. So it's going to be, so our object is basically, now I'm going to take that centripetal force, I'm going to put that on the object. Same thing we did before. So this is going to be the circular path.